Today we have to start properties of determinants. Properties of determinants. Determinant is having some properties. Using these properties, we can make the sums easy to simplify. So these properties we have to use for the next exercise. So I am going to explain all the properties one by one. The first property, if each element in a row or in a column, that means these are rows and these are columns. If each element in a row or in a column of a determinant is 0, I have written one determinant 2 by 2. This is first row, all the elements of this row are 0. Then the value of the determinant is 0. Then result of this determinant will be 0. That I have done. I have taken first row's elements 0 and second row 3 and 5. If I simplify this into this minus this into this, which is done, 5 zeros are 0 minus 3 zeros are 0 is equal to 0. Therefore determinant has first row all the elements 0 and result is also 0. Similarly, we can take one example of 3 by 3 determinants. In this determinant, third row's elements are zeros and I have simplified it 1 into minor of this plus then minus sign I have given 2 into minor of this, that is 3500 plus 5 into 3100. 5 is in first row and 5 is in third column, therefore hiding this to 3100 are left. Simplifying this one, this result is also 0, therefore this property is correct. This property is satisfied. That means in our practical cases also, if we get all the elements of any row or any column are 0, then we can write that value is equal to 0 directly without expanding it. This is property number 1. Now property number 2. If each element on one side of the principal diagonal, what is the meaning of principal diagonal? As determinants are always having same number of rows and columns, then it will be a square matrix. So this will have two diagonals. So these diagonals are left hand side top to right hand side down, that is one diagonal, and right top to left down, that is another diagonal. Principal diagonal means main diagonal, that is left up to right down. 1, 5, 3 are in principal diagonal, but 0, 5, 5 are also in diagonal, but that diagonal is not called principal diagonal. So if we take all the elements of one side of principal diagonal 0, any side, this side or this side, these three elements are 0, then result of the determinant is the product of the diagonal elements. Which product of the diagonal elements means 1 into 5 into 3. 1 into 5 into 3. So the result will be principal diagonal 1, 5, 3 are the elements of principal diagonal, and one side of this principal diagonal all the elements are 0. So if I simplify, then result should be according to the property. It is given value of the determinant is the product of the diagonal elements. 1, 5, 3 are the diagonal elements. If I multiply these three elements, 5 ones are 5, 5 3 is a 15. 15 should be the answer. Let us check it. 1 into minor of 1 means this row and this column are to be hidden, and then 5013 I have to write 5013 minus 0 into minor of 0 is, if I hide this 2, then 2053 plus 0 into this 0 into this row and this column are gone, 2551. Now if I simplify, 3 5s are 15, 1 into 15 minus 0, and these two I am not finding. 0 into anything is 0, and 0 into anything is 0. So finally result is 15, and 15 is the product of the elements of principal diagonal 1 into 5 into 3. Instead doing all directly, we can write 1 into 5 into 3. This is the second property, and third property is this: the value of the determinant remains unchanged if its rows and columns are interchanged. That means this is the given determinant whose rows are this: first row, second row, third row. First row I am writing in first column, that is 1, 1, 2 in first column. 3, 1, 1 is in second row, that is in second column, 3, 1, 1. And third row's elements are 1, 3, 2, that I am writing in third column, 1, 3, 2. Therefore, this is only known as the rows and columns are interchanged. The value of the determinant remains unchanged. This also can be done by calculating left hand side. If you find out what is the result, check it. 1 into, directly I am writing 1 into these 4 elements, these 4. 2 ones are 2, minus 3 ones are 3, 2 minus 3, 2 minus 3, minus 1 into, directly this one is in this row and this column. 3 to the 6 minus 1, 6 minus 1, plus 2 into this 2 is in this row and this column. 3, 1, 1, 3, 3 3s are 9 minus 1, 9 minus 1, and this result is 2 minus 3 into 1 is minus 1, 6 minus 1 means 5 into minus 1 is minus 5, and 9 minus 1 is 8, 8 2s are 16, plus 16, 16 minus 6 is 10. This is left hand side, and if I find right hand side, means this side, this is right hand side, then result will be remained same. Let us check it. 1 into 1 is in this row and 1 is in this column. These 4 elements directly I am simplifying and writing. 2 ones are 2, minus 3 ones are 3. 2 minus 3 minus 3 into, always we have to give plus minus plus sign, plus minus sign I have given. This is in first row and second column, so hiding this 2, 1, 3, 2, 2 are left. 2 ones are 2, minus 3 2s are 6. 2 minus 6, plus 2 into, finally 1 into, 1 is in first row and this. 1 into, what I have to write? These 2 are gone. 1 into 1 minus 2 into 1. 1 minus 2. 1 minus 2. Now if I check this result, 2 minus 3 is minus 1 into 1 is minus 1. 2 minus 6 is minus 4 into minus 3 means 12. And 1 minus 2 is minus 1 into plus 1 is minus 1. Therefore 12 minus 2 is 10. Left hand side and right hand side both are same. That means in any determinant we can interchange the rows if we require to do that. Instead explaining anything directly, we can interchange the rows and columns and we'll get the same result.